Well, hey, physics class. This is an assignment that I like to do when we're doing circuits in any physics class because it gets to what I think is a much more realistic and interesting real world problem. It's one thing to be given a circuit and saying, all right, figure this out, analyze it, and quite another to know how circuits work and be able to come up with a way for it to do what you want. Okay, so the idea is that, say you have a supply drawer or something of resistors that you can use. And so I've supplied you with four of them. So we've got a 100 ohm resistor, a 1000 ohm resistor, a 5000 ohm resistor, and a 10,000 ohm resistor. Let's just say these are the four that you have to use. Okay, so you've got resistors and you're going to build a circuit, but the circuit doesn't require or call for 100, 1000, 5000, or 10,000. It wants, say, 300. So you don't have a 300 ohm resistor here. 300 ohm resistor is not available. But can we make a circuit with an equivalent resistance of 300? Actually, you can try, you can get close, and what we're going to do with this is see how close we can get to 300. Now, there's a couple tips that I want you to have in your mind while we're trying to do this. One of them is that, of course, resistors in series add. So if you need your resistance to go up, then just put one after the other in series. But resistors in parallel are less than the lowest. In other words, if you put two resistors in parallel with each other, the total resistance, the equivalent resistance of that circuit, will be lower than the lowest resistance in that circuit, in that parallel group, that is. And it's also worth noting, I couldn't resist the three L's. Larger, lower, less. That is, if you take 100 and 1000 and put them in parallel, okay, the total resistance of that will be less than 100. But if you take the 100 and the 5000, it will still be less than 100, but it will be higher than if you had put the 1000 in. Anyway, it's one thing to just say that, but it's another to do it and show it. So what I'm going to do is I'm going to go to a fresh piece of paper. So you're going to want to, take note that we're working with 100, 1000, 5000, and 10,000. And I'm going to go through the steps of what it might look like. And when I say go through the steps, there is no one way to do this. That's part of why this is an interesting problem. It's because there's lots of ways to do this. I might not even find the best one right now. There might be a better one that I just never bothered to find because I thought I did well enough. Really what I'm going to try to demonstrate is what it's like to try to solve one of these, not necessarily getting the best answer. Anyway, so 100, 1000, 5000, and 10,000. All right, so let me demonstrate that first one. I know that I'm going for 100. I'm sorry, I'm going for 300. So I've got two different ways that I could try to do that. I could, let me write this here, start under 300 and add, like this. 100 and then something here, and that'll get it. That's one way that you could try to get 300. Start under 300 and then add up to it. Okay, what about this? Start over 300 and reduce. Okay, that might look like this. Start over 300. Here's 1000. And then reduce, like put something in parallel with it and get it down to 300. These are two possible approaches that we could take. And I guess I'm going to try one of each, see how close I can get before I can't seem to get any better. And then I'll switch gears and try the other one. So I'm going to start under 300 and add. So ideally, what it would be really nice to do is to try to get 200 out of this. That would be nice. So going back to my last page, if I can't use this, let's see if it's possible to get a 200 out of this. So let me see what I would get if I tried a 1,000, a 5,000, and a 10,000 in parallel. Let me see what I get. So I'm going to start with the two biggest ones, a 1,000 and a 5,000. I don't actually know what I would get if they're in parallel. So let me just go ahead and do that. This is a 1 kilo ohm. Here's a 5. Oops, forgot the kilo ohm. All right, what's the equivalent resistance of that circuit? Let's go ahead and figure that out. 1 divided by 1 over 1,000 plus 1 over 5,000. 833. That is too high. I'm going for I'm going for 200. That was too much. Okay. Maybe I can make it lower. So I got my 1,000 and my 5,000. What if I stuck the 10,000 on there too? Now what is it? Tell you what, let me actually write in black that this was 833.3. It was too high. I'm trying to get 200. And don't forget, the reason I'm trying to get 200 is because I'm taking this first approach where I start low and try to add up to 300. I need to try to get 200 ohms to add up with 100. 833.3 is just too much. So let me see what happens if I put that 10,000 in there. So 1 divided by parentheses. Okay, so I got my 1 over 1,000 plus my 1 over 5,000 plus my 1 over 10,000. It only got down to 769. Still too much. Well, that's the lowest I can actually get with these 3 resistors. Now, there is one assumption that I haven't questioned yet, and that's, is it really correct to put that 100 in the front? If I put that 100 in the front and leave the rest of them to go afterwards, I can't get 200. Could I possibly fix this by having a 100 in the parallel? Well, no. And the reason that I can't do that is because as soon as I put the 100 ohm resistor in this parallel, the resistance automatically goes below 100. Here, let me demonstrate. Let me stick the 100 on here, and I've already failed. Because look what happens. Let me clear that. So if I do 1 divided by, and I got my 1 over 1,000 plus my 1 over 5,000 plus my 1 over 10,000. Okay, this is where I was before. As soon as I add in that 100, I'm doomed. Plus 1 over 100. See, I'm below 100. Of course, I'm below 100 because, ouch, like I said, resistors in parallel are less than the lowest. So I have to be less than 100 because these just make it easier than the 100. Okay. Well, since that's not going to do it, my only other option is to start over 300 and then try to reduce. All right, so let me go ahead and go for that. By the way, the closest that we could get was this. Actually, let me go ahead and just, I guess I'll do it in blue. I haven't used that color yet. This is the closest that we got. A 100 in series with, I want to make sure this is actually in the frame. Yeah, this is as close as we got. If this were 100, then we had 1K, 5K, and 10K. This would have been this 100 plus that 769. It would have been 869 ohms. 3 times what we wanted. All right. Let's try a different way. Let's try starting above 300 and then reducing it. So the closest I can get to 300 is 1,000. I don't know why I didn't write 1K, but hey, there you go. So that's the closest I can get to 300 if I start above it. All right, so if I want to reduce that, I need to put it in parallel with something. Okay, well, let's try 5,000. Let's try 5,000. So if I just put this in parallel, see, now I can write K. If I just put that in parallel with the 5,000, I want to remember what that is. 1 divided by 1 over 1,000 plus 1 over 5,000. 833. Right. We had that. So 833. So that is it's too high. I need to bring it down more. All right, let's bring it down more. How about we put the 10,000 in series with, I'm sorry, in parallel with it. It didn't turn out so well. Okay, so now I've got all three of them in parallel. Didn't I do this calculation already? 1 divided by 1,000 plus 1 divided by 5,000 plus 1 divided by 10,000. 769.2. Yeah, I did this one already. 769.2. I can't get any lower than that without going below 100. So, what's the best I can do? Well, either I start below 300 and then add the least I can and end up at 869, or I start above 300 and then reduce it as much as I can without going below. It looks like I've got third place, second place, and first place. So let me rank them for you. Coming in at third place with the bronze medal is $100, followed by the three large ones in parallel, 1K, 5K, and 10K at 869.2 ohms. Let's give it up for third place. Okay, coming in at second place, getting the silver medal, we have, let's see, where am I? What paper did I do it on? Oh, right. The one I'm looking at. Coming in at second place. Oh, Mr. Estes, you're so perceptive. All right, so coming in at third place. Second place. The three big ones in parallel at 769.2 ohms, and just don't use the 100. So this is third place, second place. What's first place, you may ask? That's just the 100. That's actually the closest to 300 we could get. All right. Well, that was deeply unsatisfying. I really wish that I could have gotten closer. So part of the problem is that the values I had were so spread out that I wasn't able to make those small adjustments that I wanted to make. So I think I've got to give you guys one that is a bit better, where things are more evenly spread out. So I'm going to lay out the details of the one that I want you to work on, and you should hopefully have an easier time than me. So here we go. You are going to have a few more resistors than I did. You may use each of them once. You do not need to use all of them. You may not repeat. Just picture like you had these in a drawer and you may use any of them. So we'll go with 10, 25, 50, 100, 200, 1,000. 10, 25, 50, 100, 200, 1,000. I almost feel like I'm setting up a game of Monopoly or something. Okay. And here are the targets that I'd like you to try to hit. First, I'd like you to try to get 30. I'd like you to try to get 80. I'd like you to try to get, let's see. I want to be careful that I don't give you ones that you can just get like exactly and easily. Like for example, if I gave you 150, well, that's dumb. You just use those two. But if I gave you 120, now that would be a little harder. I know you could do 100 plus 25, but like, come on, you can get closer than that. And let's do one more. 100 plus 500. No. 450. Okay. So if I just posted that as an assignment, that would be really confusing. Maybe have a hard time getting what I'm asking for. What I'm asking for is for you to use these. You may use each of them once. You don't have to use all of them. Try to arrange them in a circuit so that their equivalent resistance is 30. Okay, scrap that. Then you can use them all again. Try to form an equivalent resistance of 80. Okay, once that one's done, reset. Try to use them to form an equivalent resistance of 120. Once that's done, reset. Try to get an equivalent resistance of 450. So this is new. It's tricky. So let me tell you what I'm looking for. What I'm looking for you to be able to do is try them all. And if you can get within a couple, like trying for 30, if you can get between 25 and 35, I mean, all right, fine, you did it. If you're trying for 80, like if you can get between 70 and 90, okay, sure, yeah, you got it. But you know, if you're going for 120 and you ended up with like 150, I don't know. Try a little harder than that. But I mean, yeah, I wouldn't want you to spend more than 10 minutes on each of these, because if you did, then you'd be spending 40 minutes on the whole thing, and that's a long time. So like if it takes you 20 minutes to get 2 of them done, I think I'd be like, all right, why don't you just check in with that? Would be a good place to stop. Anyway, I've gone on and on about that, so I guess I'm gonna just stop it right there. All right, good luck.